All right, folks, welcome to the first event in 2021 for the Atlanta Kubernetes Meetup. As always, we'd like to start off by opening up the chat and encouraging people to kind of shout out announcements about any hiring in the community, things that are kind of Kubernetes or CNCF related, all over the place. If you have something, go ahead and put it in the chat. Make sure you include some contact information for a relevant contact at the company that is hiring. And what we'll do is after the news segment, we'll go ahead and read those out for everybody. Keep in mind that'll be recorded and put up on the YouTube, and we will also post the announcements that you put in the chat on the show notes afterwards. So those will be available not just for people hiring here, or rather not attending here. So I'll go ahead and hand over to Joe to read our news segment for the first of the year.
Okay, let me get my screen shared here. And welcome everybody, Happy New Year. So we have a lot of stuff that has happened in the Kubernetes community so far. During the gap of the end of the year last year when we didn't have meetups into this first month of 2021 as well. And usually I like to go through these and prepare a little bit and read up, but full transparency, I did not have the time that I wanted to. So some of these we're going to be reading and figuring out together. So it should be fun. So general, we want to start out with Kubernetes release information like we normally do. We did see the 1.21 Alpha 1 drop. So things are progressing right along with that. Haven't seen anything that looks like it's going to have any type of delays or anything like that. If you are working on upstream contributions and enhancements, make sure you have your enhancements added to the enhancements tracking sheet. We are coming up on the enhancements freeze for 1.21 on February 9th. So just be aware of that. Other things that dropped this month were a new patch released for the latest versions. This will probably be the last patch release for Kubernetes 1.17. So if you're on Kubernetes 1.17, probably a good time at looking at moving up to some newer versions there. PRs are no, there were so many PRs to kind of go through, you know, just in this month. And the one that I picked out that was interesting the most was this one on a KEP for the Kubernetes interface definition label. And actually that might be language, I think is what that's supposed to say. But let's open this up and take a look real quick. And hopefully that loads. Yeah. Yeah, language. That's not supposed to say label. It is language. So this is sort of interesting as things have progressed in the Kubernetes like development of the entry and core API resources. There's a lot of opinions that have been developed, and this is around taking some of those opinions and structuring it in a way to make future API changes, enhancements, PR reviews and things of that nature slightly easier on the maintainers in the community, as well as new contributors that are trying to pick up and see, like, learn all of the things and how they should be building and contributing to the APIs and this stuff. There's some really interesting discussion on here, not a whole lot of information just yet. And you do kind of sort of have to like follow the tree through here to get to all of the files that are actually documenting the roadmap for this. But some of the interesting pieces on this is if you're building out like controllers and operators, this can potentially affect you. So probably a good idea to kind of keep note of what the status is on this as it progresses. And if you have any strong opinions on this sort of thing, you know, by all means, jump out there and get involved in the discussion. But definitely something that was interesting that caught my eye. Coming back in, just moving to deprecation. So this is something that's been talked about for a long time now within the upstream community across different working groups and SIGs here. And it's kind of been a general like pod security policies is probably going to be deprecated, but we never had like a date or a timeline or a schedule or anything like that. So there was a PR merged going into the Kubernetes 1.21 release. Where pod security policies are officially marked as deprecated in 1.21 and are slated for removal in 1.25. Now, I do want to bring up some of the documents here in support of this, because this is a very hot topic for a lot of people, because a lot of folks, from my experience talking with people within the community, is people are just kind of getting to the maturity level where they're actually starting to adopt and implement pod security policies. So it's kind of a big wrench that this is, has been up in the air, and the future of it is kind of unknown, or not as well defined right now as a lot of folks would like it to be. So there are meeting minutes here from some of the places where this topic's been discussed, documents to kind of track what the difficulties have been with getting the existing pod security policy implementation past a kind of alpha status, and all the shortcomings. There's a presentation here. This is actually pretty good. It's not very long. It's not super in depth. And I do recommend going out here and taking a look through this. There's one slide in particular that I wanted to jump to, which is kind of like future path options that are being discussed with the folks in the special interest group over this. And so one is obviously like, do we continue to promote the pod security policy API to something that's stable, with fixes in mind that address some of the concerns and shortcomings of the existing implementation? There's another option that is, do we just completely rip the current PSP solution out of the core Kubernetes code base and go with something else that's implemented in tree? This term OPA Lite has been thrown around a good bit. And then another option is to go with no in-tree mechanism and have more of a pluggable interface, like what you've seen with like CSI, CRI, and things of that nature, so that these things can still be implemented externally in a way that works with core Kubernetes, but leave the actual implementation mechanism up to the end user to decide, or the market to kind of create. So lots of stuff here. There was also some additional discussions out on the mailing lists. So feel free to link through those and jump out there. Again, if you have strong opinions, by all means, jump out there and get involved, make your voice heard, because this is a big topic. It's been really interesting to see this play out. I am glad, no matter which way you fall, favorable or not, on pod security policies, that a official decision kind of has been made as far as the code base goes right now. So getting into some community news here. One of the lead maintainers of the Nginx Ingress controller project has decided to step down as a maintainer. And I think a lot of people in the community have used, if they're not currently using the Nginx Ingress controller, it's been kind of a de facto place in the Kubernetes community since almost day one. And I know I can speak from personal experience. I've worked with the maintainer here on several different items. Probably one of the best gems in the community as far as like somebody that's just really eager to help everyone and get to the bottom of problems and issues as you open them up. So definitely a sad day to see them step down, but I'm sure there's good reasons for that and everything. And just wanted to, shout out and say thanks for everything you've done. It's been a wild ride, and we appreciate everything that you did there. If you are looking for a place to jump in and get involved in the open source community, they are now looking for maintainers. So if you've got some experience within the CNCF community and the Kubernetes community, feel free to jump in and maybe take on something a little extra. Same thing for KubeState metrics there. That project is also going through a transition in the maintainers there, so they have some open spots. So if that's something that you want to do, a goal that you've had, a couple places that you might be able to jump in there. Next, moving on to COSI, or the Container Object Storage Interface. This is another interesting one that much in the same way that we have the container storage interface for more of the like block storage solutions. This is bringing in similar functionality for object storage. And so there's the concept of, a definition, a claim, and things of that nature, as well as underlying a kind of pluggable interface for the provisioner side of things, whether you're using, Amazon S3 or you're using something from Minio or different things of that nature. So obviously there's a lot to talk through this because this is establishing an entirely new specification. here, but essentially, you know, it is very much like the existing PVC model of the container storage interface, but with block storage. So if you've been looking for a little more native Kubernetes declarative experience around your block storage needs for your workloads, this is definitely a place to kind of plug in and pay attention to as it progresses. All right. Next up is the KubeBuilder declarative pattern. So hopefully a lot of folks should be familiar with what KubeBuilder is in and of itself. It's a kind of framework to help people scaffold out and get started quickly with developing Kubernetes operators and controllers. And so they've expanded on that to where, from a pattern to where you kind of build out all of the type specifications and the controller logic and everything, to where in some cases, you just need to take some YAML and apply it to a cluster. And if you look at some of the work that's been going on in the Kubernetes add-ons SIG, actually, I don't know what the SIG name is, but in the Kubernetes add-on space, so things like core DNS and things of that nature, a lot of those patterns are actually moving to this KubeBuilder declarative pattern, where essentially you have a lot of functionality to where you can define like your channels, like alpha, beta, stable, different things like that for the resource or resources that you're trying to deploy out into Kubernetes. And then you're still relying on the general Kubernetes like controller runtime logic for like reconciliation, state tracking and finalizers and things of that nature. So again, just another quick way to take something, if you've got some YAML and you want to deploy it out there and kind of develop an operator pattern out of it, it's another mechanism to do that. This is somewhat standalone today, but is moving to be a plugin for the normal KubeBuilder CLI utility. So there is some work in progress right here, and it is under active development and changing, but definitely an interesting thing to check out. And then today's topic, we're talking about Cluster API here, and I won't go too much into that because I think Jason's got some good content. But this Cluster API provider nested was pretty interesting, and the Cluster API project from the get-go has had a couple different plans for how to provision and manage like the control plane components of Kubernetes clusters. They picked one way, kind of easiest way to get started first, which is to treat your control plane nodes as like another machine type. This model gives you the ability to more provision your control plane components as just pods, and a set of pods that creates a control plane for a cluster. And so it's sort of like nested and whatnot, but very interesting pattern. I think this is in line with how some of the major public cloud providers manage the control planes in their managed Kubernetes services today. So definitely interesting to see work continued on enhancing the flexibility of how Cluster API can provision clusters. Envoy 1.17 was released. There is a ton of work that went into this release, and I am not going to go through and read through all of this. So please, if you're interested in the Envoy stuff, like this is just the new features section. There's a ton of work that went into this, a lot of big milestones and setting up for some really big stuff for the continuation of things like WebAssembly adoption and integration and things of that nature. So definitely go out and check it out if you're interested in the Envoy area. Next, we have this. So we've had a couple different articles from authors in the past where they go like really, really deep into the details on how different components in Kubernetes or in client Go and things like that work. And this is one that caught my eye. And this is just the first article that it looks like the author is going to do in a series of diving into the details of the client Go list watcher method. And hopefully this loads. If not, okay. We'll move on. If that link's broken, I'll update it later on in the notes so it's accurate going forward. But again, really, really interesting to kind of pick apart the underlying mechanisms that support some of the things that we might take for granted in the Client Go library. And one of the comments that I do remember from reading that article earlier is the author talked about kind of when they only partially understand something that they can like converse on it in passing, they really like to take that and distill it down to the essence of the thing and kind of pick it apart. What are the foundational components that make it up and whatnot? So it gets into some really interesting backstory on how a lot of Client Go's mechanisms like came to be that support this list watcher feature. So if you're into the software engineering side of things, it's definitely a cool read. Hopefully things load.
This is Michael. Gosh, this is an incredible article. He really digged into it quite a bit. And I also put a link in the chat that gets into some of the details that he was able to uncover in that process around things like when you're going to do a list watch in the controller pattern and you set your revision to 0. If you're running against an API server that has a cache, that may result in time travel, interestingly enough, right? So definitely some super interesting stuff.
Thanks for that, Duffy. So that article finally loaded. We're struggling a little bit on my end to load the rest here. So here, this is a ksref.io. If my memory serves me correctly here, this is some new tooling that was done as part of one of the programs around documentation within the community. And this is a kind of new spin on how to document the Kubernetes APIs and everything. And this was done really well in a way that it's actually been integrated into the Kubernetes documentation site. So it's searchable, it's parsable, it's generated dynamically. And if you've ever had to go through and like pick apart some things in Client Go or something like that and really needed documentation, this is a better experience all around. So I also linked to a blog post here that kind of talks into like the background on this. And this was the Google season of docs. But really cool stuff here. I highly suggest check it out if you haven't already seen it. I definitely love new like technical enhancements on things and whatnot, but solid docs is something to be proud about. And I will say that the folks managing the docs in our community are doing a great job at continually pushing that. Yeah, thanks, Jim. All right. So last and certainly not least here is this Kubernetes Global Balancer. So this is an interesting thing. This is a space that I've been playing a lot in over the past year or so. So definitely cool to see some other folks bring some things to the table. But this is the, okay, I have a Kubernetes cluster and I have services on it. And I got a load balancer in front of it and that works. But now I have 2 Kubernetes clusters, or I have 100 Kubernetes clusters. And how do you start to manage the traffic distribution across all those things and whatnot in a way that makes sense? And a lot of people have to shill out to like whatever the infrastructure provider offers for APIs and things like that. And you start to get out of the bounds of like that Kubernetes declarative experience. So this is a project that has a lot of folks from the Kubernetes community jumping in on it, but is kind of a primitive solution right now to solving that problem. So think about like almost ingress plus to some degree here. But a new abstraction layer, and it uses some really interesting mechanisms, being that it's the front end of it is using DNS, but it's also using DNS for kind of its service registry under the covers. And so there's a whole bunch of DNS wrapped up into this, which is pretty interesting. There's a lot of information out here if you want to like look at the architecture and all that stuff. And I'll admit that this kind of surprised me. There's a lot of work that's been done without a lot of kind of cheerleading or evangelism about it. So when I went out here expecting it to be kind of a new early thing, I was pleasantly surprised by the amount of content that they already had out here for me, having just heard about it. But something else to check out. And that wraps up this month in Kubernetes news. So that being said, I'll hand it back over to Alex.
Cool. We surprisingly did not have any hiring announcements in the chat. Again, if there are any, go ahead and post them in chat. We won't be reading them since we're moving past that segment, but we will get posted in the show notes. Before moving on, I do want to thank our sponsor. As always, SalesLoft provides our Meetup Zoom and the storage and all that, and in Better Times provides space and food and all those wonderful things. So we do want to thank them for sticking through with us through these end of days, and hopefully we'll all get through it together. Just a quick note, our speaker has let us know that he is happy to answer questions throughout his presentation. So if you have a question you want to ask, go ahead and use the Q&A functionality. You'll see it at the bottom of your screen in Zoom, and one of the panelists will interrupt him rudely and read your question, and you'll get an answer live on the air. So with no further delay, I'll go ahead and introduce our speaker, Jason DeTiberus. He works as a senior staff engineer at Packet, and he is going to be talking with us today about Cluster-API with a bit of pixie dust sprinkled on it.
And thank you, Alex. Let me see if I can go ahead and share my screen. Hopefully that's working there. And so yes, thank you. We're going to talk about Cluster-API today and bare metal. To start with, who am I? As Alex mentioned, I am Jason DeTiberus. I am a senior staff engineer at Equinix Metal, the cloud provider formerly known as Packet, and working to bring cloud native infrastructure management into the data center. I've been building Kubernetes cluster lifecycle management since 2015, co-maintainer for the Kubernetes Cluster-API project, and for about the past 5 months or so, contributor to the TinkerBell project. To give some context, this presentation is going to be a little light on content because a couple of days ago, I thought this demo was going to be completed and I'd have a little bit more time to polish up the content. That was probably a premature celebration because the demo didn't actually work until about 5 p.m. today. So we're going to see if it will work today or not. And we'll just go through the content. And if you do have any questions, please do go ahead and ask them, and I'll try to address them in real time. So what is TinkerBell? Basically, TinkerBell is an infrastructure management application. The idea behind it is to bring cloud native infrastructure management into the data center. You know, there's Kubernetes for managing applications. TinkerBell wants to be the alternative for managing actual bare metal infrastructure in the data center. How does it do that? Well, it's comprised of a few different microservices today. They are mostly decoupled and loosely coupled to provide some functionality. But the idea is that TinkerBell isn't a monolithic application that you have to like upend all your existing management to use. It's meant to be composable, modular, and fit in with what you're already doing today, and be kind of a more pluggable, flexible solution than some of the existing infrastructure management products in space. And to do that, the main thing is the TinkerBell workflow engine. There's another service called Boots that handles the DHCP and Pixie services. There's a metadata service called Teagle, and there's a worker component that actually runs within a specialized operating system that's bootstrapped for running the workflows. And I'll go a little bit more into kind of what's going on with TinkerBell when we get to the demo part. I did want to touch briefly on what is Cluster-API. I'm not going to go too deep today because I know Joe and others have presented on the topic here before. But to give a quick summary of Cluster-API, the idea is similar to TinkerBell, managing, the life cycle of the infrastructure management for Kubernetes clusters declaratively. When we embarked on the project, we said we already have this model for declaratively managing things. Can we use it for actually managing the infrastructure for managing Kubernetes clusters? And can we kind of work around the idea of the chicken and egg scenario that you would end up with for natively managing Kubernetes clusters with Kubernetes? And so we'll dive more into that as we go along too. I'll try to describe things as the demo's running. I do see the question whether Ben Rockwood is still at Packet, which is now Equinix Metal. Yes, he is. And I will definitely reach out and tell him that. Outside of that, here's a little more breakout of Cluster-API. Basically, the idea with anything Kubernetes related, you take a big ball of YAML, you throw it at Kubernetes, and you get something out the other end. In this case, it's the infrastructure and an actual Kubernetes cluster instead of just some services running on Kubernetes. And that's really the end of that part of the demo, or that part of the presentation. I did want to touch on a question that Lamati had earlier. He had asked whether, how cluster resource sets work and whether or not they would be, what's the future on them and things like that. In general, the cluster resource sets were introduced as kind of like an interim concept. We have the idea of the infrastructure of Kubernetes clusters. We don't want to take on full ownership of add-on management for Kubernetes clusters in the Cluster-API project because we feel like others are working in that space and we don't want to kind of bring too much into the Cluster-API umbrella and the additional management and stuff with it. However, there's a gap today for things like applying CNI solutions and things like that. And cluster resource sets were kind of introduced as a stopgap measure to be able to kind of apply just some set of YAML to clusters. Longer term, I would expect the work that the add-ons management subproject in SIG cluster lifecycle is doing will eventually take over what's currently being done in cluster resource set, and there'll be kind of a better first-class support for how do you manage the add-ons for Kubernetes clusters and how does that integrate with Cluster-API. So I hope that helps answer your question a little bit there. Outside of that, we can go back. And I'm going to skip past a lot of this. Let me just go over here. What I've done is I've actually already set up a TinkerBell cluster. And let me switch my video real quick here. This is what I'm affectionately calling US East DeTiberus right now. These are 5 small factor computers and a small mini ITX box. That mini ITX box is actually hosting the TinkerBell services right now. And if you go to the TinkerBell website, tinkerbell.org, there's a kind of a quick start there with how you can get up and running using Docker Compose either on Vagrant or using Terraform to provision on Equinix Metal. I kind of modified that a little bit to deploy it on this machine. And we'll be publishing the docs for that as soon as we kind of nail down all the edge cases that were involved with it. But TinkerBell's running there. And the 5 other machines there are just small, pretty wimpy machines, but they are configured for Pixie booting off of there. And since I don't have any type of IPMI solution or any other type of out-of-band management, basically what I'm going to do is I'm going to actually physically touch and boot these things when the time comes. So now, with that said, I can go in here and in the TinkerBell system, there's basically 3 types of primitives. You have, at least as far as the workflow system, you have hardware, you have templates, and you have workflows. The hardware is exactly what it sounds like. It's just a description of the hardware that you're managing with TinkerBell. The templates are basically just a templated script that you want to run. And I'll run through what those kind of look like when we get to them. And then the workflows are basically a concept to tie a template to some hardware and actually instantiate that workflow to actually do the thing. So if I come in here, and this is, I'm actually SSH'd into that machine right there, and just do a hardware list here, you'll see there's 5 hardware definitions there, and those match up with the 5 Pixie boot boxes that I have there. And if I go and list any templates or workflows, I don't have anything. Oh, wait, I was wrong. I do have something there. It's a workflow to actually wipe these disks when I'm done, because I'm working around a bug, and I'll get to that in a moment. But right now they are set to boot from disk first and then Pixie to avoid kind of a reboot loop that was happening. So in order to actually make the demo work, I have to wipe the disk in between turns to ensure that it will Pixie boot, and then it breaks out of the reboot loop and will actually boot up to the disk. But other than that, there are no templates defined. And if I go in here to the workflows, I believe I've deleted all those from earlier, and those should be empty. Let me see. Yeah, workflow, not workflows. And there are no workflows defined there. So that's there. Now on the Cluster API side, I've already stood up a Cluster API deployment into a local kind cluster, and that's running using Tilt. If you're already familiar with the development tooling for Cluster API, it's the exact same type of setup there. I'm trying to work to actually have a full setup where you can deploy TinkerBell and Cluster API all with one Tilt up command. Not there yet. If we have some time afterwards, I can go into some of the issues that I've hit into there, and how do we solve those, because I can definitely use other folks' help if you have some ideas on how we can solve some of those issues. But with that said, what I can do here is if I do kubectl API resources, we will see that in addition to the normal Kubernetes resources, I actually have some TinkerBell resources here. And that's mainly because what I've done is I've modeled out the actual TinkerBell resources in Kubernetes, and there's a shim layer that's running in between Cluster API and TinkerBell. And you know, I can explain more into what's going on there when we get there. And then we have the Cluster API resources in here somewhere as well. Yeah, the infrastructure.cluster.xhkates.io, and it should be the other ones there too. Yes, and the cluster and all that. So if I come in here, do a get cluster API, nothing's defined yet. I don't have any clusters. I've already pre-created a few of the hardware resources in there. And if I look at that, what you can see here, that's actually the wrong definition. That was for the VM version. But you can see here, the definitions really only have an ID. So you specify the ID of the already existing hardware in TinkerBell, and that connects the Kubernetes CRD resource with the TinkerBell resource underlying. So if I actually do like a kubectl describe on the hardware here, what I see is even though I only defined it with an ID, it's actually pulled all of the information about that hardware that was actually defined in TinkerBell. So we can see, at least for this one, it's ready that the IP address that it will assign is 109. You know, it's got all that information there, and it's ready to go. It's configured to allow Pixie boot and to run workflows. And if I do a get on templates and workflows, we'll see that there aren't any in here as well. But now what I can do is, let's create a test cluster. I'll get that started. And this test cluster, if you're already familiar with Cluster-API, it's pretty much a standard definition, although I did add a little bit of config in here to configure a user with a relatively insecure password here because it is running locally just for a demo, and an SSH authorized key. And everything else is pretty much what you would expect. Nothing really unexpected there. But if what I do right now, if I do get cluster API, we can see that it's already started working in the back end. It's already sat there and defined a TinkerBell machine, and it's actually referencing a TinkerBell instance ID right here. And this instance ID actually matches up with the hardware that's defined. So this is the same ID as the hardware. And because I wanted to make things easy, I made sure that the UUIDs for all of these ended with a letter that is associated with the hardware that I have over here. And I can do the split view here. And I'll go ahead and power on A while we're going through the rest of this. So that instance ID tells me that it's for that A hardware there. And if I do a get TinkerBell here, what we'll see is I actually now have a template and a workflow here. And what Cluster API is, or what the TinkerBell provider is doing right now, is it will create a new template and a new workflow for each machine instance that we're creating now. So if I look at that template, what we'll see is there's actually a lot of stuff in here now. So what we're doing is we're basically, this is what I would call early proof of concept work. This is not what it will look like long-term, but we're trying to work around the edge cases that we have. We're trying to integrate the products right now. So we're full of a lot of workarounds. Eventually, we want to match up with what a lot of the other Cluster API providers are doing now, which is building kind of base images for each Kubernetes version, and then basically bootstrapping those and just injecting like the bare minimum like cloud init user data that you need to actually get it actually running. We don't have kind of that image management concept with TinkerBell right now, but we're hoping that this work will help inform how we can actually add that functionality. So in the meantime, what we're doing is we're basically doing all of the bootstrapping against a bare Ubuntu cloud image right now. And what you see right now is we have this TinkerBell template define some tasks, and you can specify multiple tasks, and each of those tasks can have one or more actions. And all of these map to actually Docker images. So where it says Ubuntu install right here, this is actually an image that I pushed to Docker Hub earlier, and then also pushed into the a local registry that's running on that TinkerBell machine right now. So it's not actually pulling directly from the internet, it's pulling from the local registry that I have here. We're looking to add support to just pull natively from upstream registries, but we also want to keep that ability to have secure known good versions somewhere else so that you don't have to deal with tags changing upstream or any of that unexpected nature. Or if you want more of a isolated environment, we expect all of that to work here as well. But then what are we doing with that? We're echoing basically all of that user data right now, and we're just dumping it in the container right now. And what we're going to do is basically when we write that image to disk, we're just going to dump that user data into the disk image right now. Longer term, I mentioned the Hegel metadata service. We want to have native integration between the Hegel metadata service and Cloud Init so that we can actually just load the user data into Hegel, and then Cloud Init will pick it up from there and work just like you would in a normal cloud provider. And then this is where it gets nice and a little messy right now, but we're actually just pulling a modified version of the Focal Server cloud image, the Ubuntu cloud image. And as I was coming up with this demo, what kind of bit me was all sorts of weird things around all of the tooling that we were using, whether it was the custom operating system we're using for running the workflows on this hardware, or the actual Ubuntu system that I'm installing on the systems. They didn't have the drivers for this old crappy hardware that I have, specifically related to eMMC storage devices and the Realtek driver for the networks. So I've spent a lot of time kind of hacking those things to kind of get things just enough to work. But it's highlighted some interesting problems that we're going to have, and we're going to figure out how do we solve those more natively. So yeah, we're just dumping that to disk. We're just using QEMU image convert to write it to the target device. And you can see here, there's like nastiness around how we're doing the block device detection. Again, the original demo was working against like virtual machines, and we assumed VDA for everything. And when we threw this at real hardware, that fell down really quick. So that's the quick and dirty workaround to get around that. And then after we copy it over there, here's where we're actually copying that cloud config file to the disk, and then doing a little bit of setup as far as the CRI. And then we unmount it. And then this is the other aspect that we hit, is that there's not a native way to do rebooting after the end of a workflow. So you can install things just fine. But the idea with the general TinkerBell project is that in most data centers, you're going to have some type of lights out management system. And there's a PB&J service that is part of TinkerBell that you can use to actually interact with that software. However, in US East DeTiberus here, we don't have that. So instead, what we're doing is just, basically doing an immediate reboot here. And this is why I was getting into that reboot loop that I mentioned, is because it's hitting this and it's never finishing that workflow. And because it's not finishing that workflow, when the hardware comes up again, it's trying to pixie boot back into the workflow OS to sit there and try to rerun the failed step of the workflow. So that's the template. And if I come here and just look at the workflow, what we'll see is it pretty much looks exactly like the template. However, what it's going to do is it's actually going to link to a specific, it's going to link to a specific worker instead. So anywhere in the template, we had previously defined, just like a templated reference to hardware, it's actually filled out in the workflow now. So now what I'm going to do is let's see if that actually worked. Without looking at anything else, I'm just going to see if I can get a kube config from here and get nodes from it. So, that helps if I write that down, huh? And it did not, unsurprisingly. So what we can do here is I'm going to step away from the mic for just a second while I actually plug in the keyboard and the monitor, and we can see where things kind of fell apart.
I mean, to be fair, US East is usually where you're going to have problems, so it might be a naming problem.
That is a good point. Amazingly, though, I am actually surprised we are actually in Ubuntu now on here. So I'm wondering if I just didn't give it enough time. Because if I come back over here and I'm going to go into the TinkerBell console here, and I got let me get this, the workflow ID, and if I do this, I can see it actually ran all the way through, and it into there. So things worked more than they didn't work so far. That's a good thing. We still don't have anything there, so I'm gonna step away and type on this machine and see if I can figure out what happened with the Cloud.init run.
This is the beauty of live demos right here, folks.
Especially when you consider the layers of complexity involved here, like you know, doing programmatic provisioning of a complex system on real hardware, or in this case VMs, right? Like, not trivial.
Okay, so funny enough, it looks like it couldn't actually install containerd. kubeadm not found. So it looks like, oh, it's a temporary resolution failure. So fun. I think we just had a transient failure. So what I can do is I can actually go back and we can prove that hypothesis. All right, let's just delete that cluster. And longer term, we'll have better ways of kind of dealing with these types of issues. But like I said, this is really early POC level quality right now. So for right now, the only easy way to do it is to basically delete it and recreate it. So let's do that. Let's figure out, oh, it actually created it on the same hardware. So that kind of makes it a little bit easier for me. I'll have to intercede here because it actually has a an install on this hard drive now. So I'll actually have to try to catch it before it makes it past the boot screen. And let me switch over to the hardware cam. So what we can see right now, and I know it's not the best view of the monitor, but right now it is actually Pixie booted. It is loaded iPixie, and now it's starting to work on more or less the Pixie boot process. So here we go. All right, now we've downloaded the kernel and the initial RAM disk. I did mention that we have kind of a custom operating system. If you go to the TinkerBell.org website, that's pointing to a project called OC right now that is kind of a heavyweight Ubuntu-based dish. I might be wrong about that. It's either Ubuntu or Alpine based, but it weighs in pretty heavily because there's a lot of stuff that's being used within the Equinix Metal environment. That's really meant for doing a lot of things like the firmware management on the systems and a lot of the boot processes that we have internally. So we've started on a forked project that we are calling, I think it's going to be called Tinky right now, Tinkie, kind of a play on OC, but with Tink. And it's based off of Linux Kit instead. So there's not really any information out there now, but it's a custom Linux Kit build. And for this environment specifically, I had to hack it up a little bit more to put in a custom kernel with the right drivers. But I believe that seemed like it ran really fast. but we'll see what happens with that. It looks like it actually completed the process, and I can go back here, get the workflows. Yeah, and it actually did complete the process apparently. And it's rebooting now, and we'll figure out if this thing will actually become a Kubernetes control plane instance. One of the other shortcuts that we have right now is we only really have support for a single control plane right now, and it's basically using the IP address for that instance when it provisions as the control plane endpoint right now. We will eventually do what we can to add support for KubeVip so that we can actually have a not necessarily a load balanced IP address, but a BGP managed shared address between the three instances. And then we'll be able to have HA control planes. And we are booting into Ubuntu here, so we'll see where this goes. And on the other side, let me get back into that other screen. Pull down that kube config. The fact that it's getting this far to me is amazing, because I did not get past this point until 5 o'clock today. The fun part about it is the cloud instance for Ubuntu doesn't have much support for hardware, and they don't have just like a disk image version of the server OS. So I ended up having to like connect in, add additional modules, rebuild initial RAM disks, and grub configs, and patch up that instance so that I can actually have an OS here. Longer term, we'll have the ability to build images, host them somewhere, and boot off of there. So let me go over here and tail the Cloud Init log. All right, it looks like we're actually talking to the Ubuntu servers now. So I think the transient DNS failure is behind us now.
Hey, Jason, quick
Yes.
question. Do you see a lot of like customization to things like Grub or like the iPixie type level components through the work that you folks are doing in this space? Or do you think you'll be able to get by with kind of more external bolt-on type solutions?
So the hope is that we'll have a decent generic solution available for folks to consume, but we want to have processes and methods for folks to customize the bits as they need. So we'll publish when we have something working better here. We'll publish them for folks to be able to consume if their hardware supports it. But we do want to have a process for folks to build custom images at all of the different layers if they need to, because anybody who's dealt with the bare metal hardware space knows that you're dealing with nothing but snowflakes, whether it's the actual Pixie Boot implementations, like how certain hardware supports the Pixie Boot specification, or different hardware level drivers, things like that. We don't want to have any type of solution that forces folks not to be able to use it because of having obscure hardware. And at this point, we've actually installed all the Kubernetes bits. We've created the static pod manifest, and this is using kubeadm on the back end. And now we're waiting for those static pods to come up. So hopefully those will come up here pretty quickly. And then we will actually have the beginning of a Kubernetes cluster.
quick question. So as you're doing this, iPixie and things like that don't necessarily have a whole lot of security built in. Is that something that y'all are looking at at all as far as, you know, when you're serving this stuff out via iPixie?
So I'll be truthful. Right now, we're not looking too much at the security perspective right now because we're trying to get the basic components down. However, we don't want to preclude the use of security. So all of the components have the ability to be TLS secured right now, and things like that with client certificates and with usernames, passwords. A lot of the stuff for the demo example is pretty wide open. Like I'm connecting to TinkerBell without having authentication credentials from the Cluster API side. That said, that's another thing. Like ideally, we'd have a solution that works the best for like the 80% use case, but we don't want to preclude folks from doing additional things. So anywhere that would become a requirement, we'd love to help support that within the community. And I think we actually have a control plane instance now. So let's see. We do. This is the first time running in front of anybody else that I've actually provisioned a control plane instance on this physical hardware with Cluster-API and TinkerBell. So
Saw it here first, folks.
Yeah. Exclusive to the Kubernetes Atlanta meetup.
And this gets me to where I haven't really done enough in the script, so I actually have to find where I am and copy and paste the oh, I didn't even put that in this part of the script because I'd never got this far. So let me go to the Cluster API quick start here and grab the bit that I need to deploy Calico.
While you're doing that, Jason, I'll continue to distract and interrupt you with a question from the chat. This is from Lamati. It says a bit off topic, but what methods do you use to monitor hardware health? After spending years inside GCP, AWS, Azure, I've lost touch with what is available to tell if a given piece of hardware is healthy.
Yeah, so right now, we don't really do much within TinkerBell. The idea would be is that anything that we would do in that area would be like an additional add-on service. I'm not sure if it's planning that we'd have some support with it of it within PB&J related to the integration with the lights on management systems, but we figure that would be you know, it wouldn't be something that we built directly into the TinkerBell workflow engine. So that I actually have a ready control plane now. And at this point, we might as well take it a little bit further and see if we can add a actual worker node to this thing. And what is my test worker A? Let's see if we can actually do 3 of them. So as soon as these tell me what hardware they're assigned to, and maybe this will work, maybe not. We're really in uncharted territory with the demo now. Looks like it's waiting on Bootstrap data. And I don't know. Well, it looks like something's hung up now, and I'm not going to push my luck too much more with this, but hopefully you get the idea of how the two projects can integrate. We're going to continue iterating on this. One of my goals is to not only have something that you can demo on your, be able to recreate on your own hardware. We do have a Vagrant-based setup for TinkerBell itself. And we have the ability to set it up with Terraform on Equinix Metal if you want to try that, built into Quick Start on the tinkerbell.org website. And I can, it's basically right up here in the setups, the local setup with Vagrant or the Terraform setup. We're also looking at how do we expand the documentation so that you can deploy the individual components by themselves a lot easier. Right now, we have the Docker Compose stuff, and if you want to try to do it some other way, you have to kind of reverse engineer it. We're going to be working very hard over the next month or so about breaking out documentation for running all of the individual services themselves. We're also working on how to get those running better in Kubernetes themselves. And the original demo that I was going to do actually involved running everything within a single kind cluster using KubeVirt as the underlying infrastructure. TinkerBell deployed on there, Cluster-API deployed on there, and KubeVirt, and everything talking back and forth. I was able to get that all working on a Linux host where basically using Multis and some hacky routing tricks, basically everything could communicate over a Linux network bridge over an L2 network that's separate from the Kubernetes pod network. And that worked great until I need to make sure that that traffic can get out of the cluster correctly and not have it now natted in the wrong places. And then I could talk to it over there. The problem is if I tried to recreate it on a Mac, because of the way that Docker for Mac works in a VM, you'd actually have to enter the VM and do some configuration changes there. And it was getting a bit wonky. So I'm hoping over the next few months, when it's not crunch time anymore, I'm going to actually reach out to some better experts in the CNI space, and also with the folks at the KubeVirt project, and figure out what can we do. One of the things I was hoping is that the Mac VTAP support in KubeVirt would help what I was doing, because it would help, because everything I was doing right now was through a whole bunch of linked Linux bridges. And once you enable NAT there, if it touches another Linux bridge, you're getting NATed, even if you're not talking to a different network. And that was causing issues with the way that the Pixie Boot service or Boots expects that the MAC address and the IP address that are coming in are authoritative instead of being natted, and cause all sorts of problems. Where was I going with that? But yeah, so ran into all sorts of issues there. If you do, if you're deep in the networking space and you have ideas on how we can help this out. Oh, the Mac VTAP. I thought Mac VTAP would help that out because it creates a actual file network and a file handle, and it allows you to route away from some of those bridges and would allow you to get away from some of the places where things were getting natted. However, if you create a Mac VTAP device inside of a container, the device file that's created gets created on the host system, not within the container. So there was no way for the CNI plugin to find the tap device that was created to be able to replicate it and map it into the KubeVirt VM, and things blew up, and we're in weird kernel territory with things that support namespaces versus not. So hopefully we'll find a better solution to that, because currently it only works on Linux. And then to get outbound traffic working right without hacking, like creating hacky CNI plugins, everything's being routed through another pod that is configured to forward the traffic out to the cluster, which is definitely not ideal to have all of the traffic from your VMs going through a single Kubernetes pod for egress. So yeah, happy to answer Any questions or?
Yeah, I noticed that there's been some discussion of Ignition as a bootstrap provider for Cluster API. Is that something that you foresee going forward, or do you have any thoughts on that?
Yeah, so there's several things that we're looking at longer term. Shorter term, I know some of the folks at Convolk are looking at how they can enable it. I think there are some thoughts that potentially a separate bootstrap provider for Ignition for right now would be a nice short-term stopgap to just get things working for them with the use cases that they have. However, longer term, we want to better build out the abstractions that we have between what's currently bootstrapping and infrastructure management. Right now, it expects a big thunk that is cloud init, and then there's a bunch of expectations on the infrastructure provider side, especially for things like AWS, where we're creating like secrets in AWS and burying the bootstrap data that way. But the idea is better build out those abstractions, find the right place to put the different components that interact with the bootstrapping so that we can swap out things like Cloud Init versus Ignition a lot easier. So I know that's not really an answer, but if you have any ideas, we're happy to collaborate on how we can better enable that.
Oh, sounds good. Thanks. I guess this is also, I'm happy to yield the floor if anybody else has questions, but I noticed that y'all pulled out of, or it looks like y'all pulled out of the Bandwidth Alliance with Backblaze B2 and some of those other storage providers for free bandwidth between the two. Are y'all planning on implementing your own object storage? Basically, my use case was pulling a bunch of stuff out of B2, in and out of B2, hosting registries there and stuff. And it would be nice to be able to, and then kind of ephemeral packet clusters. Is that something that y'all are thinking about at all?
I can say authoritatively, we won't be looking at any type of managed offering around object storage. I know there's a lot of efforts around how do we better enable community and community-based projects and commercial products that offer object-based storage and even block storage for customers, whether it's integrations with Kubernetes or for other uses. I'm not really familiar about kind of some of those partnerships, the partnership side of the house, though.
Cool. Yeah. I mean, I've also been running Minio to pretty good effect. So it's like, just drop Minio on a big beefy storage box, and sometimes you're done. So.
Yeah.
I see
Sure.
Lenati's question in
Yeah.
the chat. Biggest question is, when will Cluster API be stable? And I am going to sit there and kind of answer this with a non-answer. What I will say is from the perspective of the actual binaries and containers that are being shipped to actually run Cluster API, I would argue that it is already kind of production stable. It's already being used and shipped in various products at various different parts of its life cycle. From various different vendors. There are already a ton of people who are using it in all sorts of different sized enterprises, either from upstream consumption or through vendor products that are shipping support for it. So I would say it's already stable from a project's perspective. The only thing that isn't currently what I would call stable is the underlying APIs that we expose, either on the Kubernetes side or on the Golang side. And I would argue that we are better served right now by keeping the Kubernetes APIs in an alpha state, because we've already mentioned that we want to offer the same type of support for our APIs as upstream Kubernetes does. So as soon as we move past alpha, that means we'd have to support for any given, right now, minor version release. Eventually we'll move to actually major version releases. But for any given release, we'd have to support multiple API types and the conversions between those right now. Since we're still building out some of these abstractions, like currently we're working on a load balancer provider abstraction for V1 Alpha 4, that gives us the ability to move a little bit quicker with respect to these things. If we sat there and rushed the API types to beta or GA at this point, that would take some of the effort it takes to add things like a load balancer provider are already kind of daunting between trying to gather community consensus on some of these things, as well as gear up the actual engineering muscle behind it to actually implement them. It would take those efforts even longer. It would take something that currently takes about 3 to 6 months and probably push it out to be a year plus project to kind of make those changes and be able to support those changes. So I'd like to see us continue to flesh out those abstractions. And one of the things that got me intrigued about working at Equinix Metal and also working on the TinkerBell stuff is I feel like the bare metal experience helps really push the abstraction a lot further than if you focus on things just like AWS, GCP, or Azure, where you have a lot of these managed services. And it's not just bare metal provisioning that has some of these problems, but even virtualized infrastructures have a lot of these problems where the load balancer that you may want to consume isn't going to necessarily be tied directly with your infrastructure provider of choice. So I think by fleshing out some of these mechanisms, getting load balancer broken out, maybe getting something like the networking concept broken out so that you can integrate with actual infrastructure switches in various places. Or if you're looking at like virtualized environments, different vendors have different ways to tie in to their physical fabrics into virtual infrastructures, be able to support those types of things. We also need to look at how do we support things like IPAM management for places that don't necessarily have global DHCP support and that sort of thing. And really, pushing things to the edge with Cluster-API in an environment where you don't have all of those fun things helps uncover some of the places where the abstractions are currently falling apart. And it doesn't just benefit bare metal, it's also going to benefit things like the other cloud providers too, so that we can make it easier to swap out load balancing implementations, whether you want to use an ELB Classic or an NLB for an AWS cluster, or if you're a fan of security groups, leverage security groups, or if you're a bigger fan of using some of the firewalling capabilities that comes with AWS VPCs, you could choose different implementations on that side too. And that's not even getting into some of the things that we're doing around the various managed or managed Kubernetes offerings and integrating Cluster-API there too. Or Joe mentioned the nested Cluster-API provider. These are places where we definitely want to have support for these things. And I think making sure that we have the abstractions right to support all these various use cases that we say we want to support is more important than kind of rushing the API types to GA at this point. Okay, any thoughts on how KCP will play out in CAPI? And to clarify a bit more, KCP is a kubeadm control plane, and CAPI is just Cluster-API. So the kubeadm control plane, basically the main reason why we brought that in, there's a lot of people that are already doing a lot of similarities, and a lot of the things that we're doing in Cluster-API are trying to take some of the best experience of various folks who have had to manage various Kubernetes infrastructures over the time and try to bake in some of that knowledge. The whole idea of a Kubernetes operator baking in the knowledge for managing that application, building in the smarts there, try to bake that in into the management of it itself, so that one, not everybody has to recreate the same wheels around managing the various aspects of Kubernetes control planes, but also so that we can also have support for the latest features upstream. We're working on tying Cluster-API directly into the upstream release testing. We're currently release informing. We're trying to get things starting to get into the release blocking test. So if anything breaks support for managing control planes, or if people want to get new features tested, the support has to come in and have that supported through Cluster-API. As far as being able to understand how stuff works when it breaks, hopefully we'll continue improving our documentation to better describe how those things work. Things like the kubeadm control plane are mostly trying to leverage things that kubeadm's already automating for a lot of people. And the final aspect is we're trying to improve observability of things within Cluster-API between conditions and events. We're trying to make it so that as things happen on an individual component level within Cluster-API, all of that stuff gets summarized and bubbled up into the higher level resources, so that if something's wrong with your cluster, you can look at the cluster resource, see that, and have basically breadcrumbs that you can follow to the point of issue, and you can continue to troubleshoot there. We don't want to hide away the complexity for all of these things, but we want to make it easier for users to manage these things safely and correctly. And we also want to make sure that they have the visibility when things go wrong, to be able to look at it from a top-down perspective of looking at the high-level resources and tracing down into the more kind of provider-specific areas, so that they don't have to necessarily know the entire architecture to even start debugging any particular issues.
Okay. I think we're gonna wrap up Q&A here. But if anybody has additional questions, definitely reach out either on Twitter or on GitHub, or reach out to myself and Alex, and we'll get you in touch with Jason so we can get you answers on those questions. Also, our the Slack channel for the Meetup and the Kubernetes Slack organization. Jason, I think I did see that you joined in there, so have the ability to talk to Jason directly there as well. That being said, huge thanks to you, Jason. That was awesome information. I know I learned a lot. Seems like we had a lot of engagement from the members in the community tonight, which is always great to see and hear. And go ahead and extend your welcome back anytime. The very interesting projects to kind of see in action with the bare metal side of the Kubernetes ecosystem. So thanks again.
Thank you for having me, and thank you for putting up with my broken hardware.
So now want to move on to like our typical call for speakers, but we're going to do it in a little bit different format this time, and hopefully it brings a little bit more back to the group. But I'm going to share my screen one more time. And as we're planning out this year of different meetup topics and whatnot, we have some various topics that are kind of carried over from comments and people that have voiced those things out last year, carried over into this year, but want to give people an opportunity. If you have any topics that you definitely want to hear about throughout the year this year, please call them out now in chat, or if you're in the panelist list, unmute and call them out. And I want to capture them in a document, and we're going to either put together a poll or create GitHub issues on our Meetup repo, and let people kind of vote to prioritize topics. And then Alex and I are going to go out and, beg, steal, and borrow for people to come in and talk about these things. So Yeah, so go ahead. We'll leave this open for like maybe a minute or two. Please call out, push topics, and we'll try to capture them here. One other thing too is we do want to try to mix things up a little bit by having some kind of lightning talk sessions. So we can pick like a major topic, and then what we'd ideally like to see is to have 4 or 5 different folks from the community kind of come in and just talk about how they handle that particular thing, you know, in their shop. Just quick, short. You don't have to do a big presentation. You don't have to talk for very long. But just to see some of the kind of diversity and the different solutions that come about within the community is one of the thoughts we've had to mix things up a bit this year. So Alex, I don't know if there's anything coming through in the chat or whatnot. I don't have the chat up right now.
No, not seeing too much people, just saying that was a great talk, and adding more accolades for Jason, and just seeing things went well tonight. I don't see any new topics though. We do also want to add even topics that any of you yourselves want to speak about. As always, get in touch with us. Don't feel like you need to be you know, a titan in the community like Jason in order to come and speak. We really want everybody to feel welcome to come speak. We want to be addressing concerns and interests at all levels, whether you be new to the community, intermediate, wherever it might be. You know, don't feel intimidated. We really want all levels of speakers. So reach out. We'd love to have you.
I would say, you know, I'm kind of a log fiend, and I would love, you know, the open telemetry. You mentioned logging there, but you know, just like what logging people are using. Like, are they using, you know, CloudWatch logs for EKS? Are they using Loki? You know, I heard that Grafana has been doing a big push for Loki as far as you know, Prometheus-like log collection. So you know, what are people using for that? Are they using Graylog? Are they using some other sort of vendor? Be super useful to know.
Yeah, I'd like to understand somebody who's actually found like quality tooling to actually look at CloudWatch logs.
Yeah, for CloudWatch logs, I've used CloudWatch Insights, and it's super powerful, but it's also expensive as hell. So, you know, there's both sides to it.
Yeah, I know they push Athena, but once again, you get, you know, just like, you know, you go into like Elasticsearch or, you know, Splunk, but once again, you're paying money if you want the commercial support. This is an interesting thing. We'll take it offline.
Okay. So I'll wrap up this section, but please reach out. You know, we definitely want to make sure that the topics we're covering are pertinent to the community here, and not just things that myself and Alex want to hear about. So, and also, yeah, definitely please reach out if you're interested in presenting. We will always prioritize folks from the community over, you know, any type of vendor type thing or whatnot. So. All right, that being said, I do want to announce our February meetup. I don't think we have the date specific yet, but we do normally try to target the last Wednesday or the second to last Wednesday of the month. But we do have a speaker lined up, and that is Casey Wiley from Solo.io, who will be talking about modern networking and Kubernetes through an edge gateway. So should be an interesting topic that's kind of continuing on some of the past presentations we've had last year. So please come back out. We always appreciate you. Again, thanks, Jason. Everybody else that came in. We'll see you next time. We are going to stick around for a little bit of social time. So I think we'll get everybody moved over to panelists so everybody can unmute and talk and come on video. So hang on if you can.
Thanks for coming, everybody.